Let's follow the analyst as he used the VolumeSTCube. He analyzed China's air quality in the first half of 2018 using VolumeSTCube. The ST series of air quality was visualized with volume visualization in the spacetime cube after they were transformed into volumetric data. The XY plane corresponds to the geographic map, while the Z-axis represents time. Each voxel denotes the AQI value at that time at a geographic location. The higher the value, the worse the air quality and the more red and opaque the voxel. First, the analyst could observe the entire dataset. To focus more on the moderate and severe air pollution, the analyst raised the voxel threshold to 150. The analyst paid attention to two regions of his interests, Western China and BTH region. In Western China, he observed frequent severe pollution. To analyze the air pollution situation in Western China further, he applied the volume spotlight to select this range. The region was exactly the Xinjiang. He clearly observed that starting around March, multiple significant air pollution events occurred. During these events, the air quality in Xinjiang deteriorated notably, possibly due to the poor atmospheric dispersion conditions and the influence of dust storms. Also, the BTH region, the capital economic circle of China, was selected. Overall, there were only a few episodes of moderate or higher pollution levels in the BTH region, and they did not last very long. Moreover, starting from April, the overall air pollution in the BTH region consistently remained below the moderate level. The analyst explored the air quality in China at some specific timestamps, like during the Spring Festival, from late March to April, and also in late May when two well-known dust storms swept through northern China. During the Spring Festival, from February 9th to March 2nd, the analyst observed a low air quality levels nationwide. With volume slicing, the analyst selected the time range. Only a few voxels were observed. This indicates that during this period, there was little moderate pollution across the country. Next, the analyst further narrowed the time range to New Year's Eve and the first 2 days of the new year. Looking from top to bottom, the analyst saw that voxels only existed in north-central China and tended to be transparent. In other words, only north-central China had moderate air pollution during these 3 days. Between late March and April, there were several dust storms reported by different media outlets in China. The analyst selected this time range by slicing the volume again. Severe pollution occurred in Xinjiang as voxels were very red. Also, there was moderate pollution in many areas besides Xinjiang. To analyze how widespread the dust storm's impact was, the analyst adjusted the map in the upper plane and specified a 3-day time range. Due to the dust storm, a large region of northern China suffered from moderate to above-average pollution. Furthermore, the analyst lowered the voxel threshold to 100 to identify lightly polluted areas caused by the dust storm. The impact of this storm covered the 3 northeastern provinces, the Lus Plateau, and half of the North China Plain. There was also a dust storm in late May. The analyst also specified a 1-day time range and analyzed the spatial impact of this storm. Mainly, the regions around the Taklamakan Desert and the Badain Jaran Desert were moderately polluted due to the dust storm. The spatial range of moderate pollution caused by this dust storm is smaller than that caused by the above-mentioned dust storm. VolumeSTCube can also support spatiotemporal analysis well. The analyst could quickly identify many hotspots and the propagation processes of air pollution. In the bottom portion, a voxel cluster was evident. Such a skewed shape signified the spatiotemporal propagation process of air pollution. To render the ISO surface, the analyst opened the surface rendering mode and set the voxel threshold to 125 and the ISO threshold to 150. Now, the analyst could clearly discern the propagation process. To analyze the process in detail, the analyst clicked the surface, actually the anchor. As a result, spatial selection, temporal selection, and zooming in functionalities were automatically issued, thereby eliminating the clutter from other visual elements. The analyst could obtain 3 pieces of information. First, the pollution generally propagated toward the southeast. Second, the propagation process appeared to be a round trip. Third, the pollution once spread to the southwest. Identifying these visual patterns could be attributed to the surface rendering with lighting information. The analyst narrowed down the time range to 1 day and moved the range along the timeline to investigate the fine-grained propagation process. The moderate pollution started from the Lus Plateau. Then, the North China Plain, Hunan, and Shanghai were successively affected by pollution. Air pollution in Hunan and Shanghai disappeared early. The analyst also noticed another propagation process. He clicked it. Pollutants spread to the southeast again. In addition, it had a flat base, which meant the propagation process was rapid. The air pollution first occurred at the junction of Hunan, Shandong, and Anhui provinces, quickly affected and covered the whole Yangtze River Delta, and eventually dissipated in the Yangtze River Delta. Thanks for watching.